hopefully I've given you enough information, and I'm going to write the solution now. And we're going to be using a lot of the things that we've already looked at here. So we figured out the number of mutations, and we're going to be needing the random module. So here in my code, I'm going to import random. And one of the first things that I need to do is to set my random seed to the value that I've got for seed. And the default value for that is going to be none, so it's just the same as not setting it at all. I need to do that before I do anything else so that anything having to do with the random module will be affected by the setting of this seed. So I have the number of mutations that I want. I've got the text. I need to figure out what are the places, the positions that I'm going to be modifying. And let's see, how did I write this? Let's see. Okay, so we're also going to be importing the string module. Import string. And the other thing that we talked about was I showed you here um, how we selected the alphabet. Let me go here. That our alphabet that we were going to choose from is going to be made up of the ASCII letters and the punctuation. And then here, the way I wrote this was I figured out the length of text, I figured out the number of mutations. And so what I'm going to do is I need to create, I'm going to go through for each, for index in random sample, and I showed you this earlier, that we can use random sample using the length of the text and the number of mutations. Let me just pop that in here. So this will give me, for instance, let's just print index and make sure that, and I don't need this here. So I definitely recommend that you just run your program a lot. Let me change this to 0.8 and it should be a lot more. So it chooses a lot of positions here. So this seems to work. Let's just do it for 10%. Great. So these are the indexes. So instead of index, what I want to say is, one of the ways I could do this is I could overwrite the value of text using text up to the index plus some sort of random choice from the alphabet plus the rest of the text starting from, let's see, starting from index plus 1 and going to the end. And if I run that, that should change 10%. Let's change mutations 50%. Oh, and it here because I'm changing text, and then so it's changing both of them. So what I actually need to do, let's see, how did I do this in the solution here? Yes, I set new text is going to be equal to the text so that the original text doesn't get changed. So I need to be accumulating these. So I need to change all these to new text. Now with that, you said the quick brown fox, and then I heard because I need to put new text here. So let's try it again. That looks pretty good. Let's run make test and see how we're doing. It's not quite happy. Well, our program isn't quite happy. If we run make test here, we'll see that it's failing because it's well, it's just not making some of the right choices here. And there's a special little caveat that I added to this solution. What I wanted to make sure, I wanted to ensure that there's no way that I could randomly replace our new character could possibly be the same as the existing character. So let's take this idea out. We're going to create some sort of a new character, and I'm going to show you how I did that. So new character, what we've been doing up to this point is replacing, we're making a random choice from the alphabet that we decided we were going to choose. But here what we want to do is we want to call alphabet.replace, and we want to replace the current character with nothing. So something with the empty string. And that thing that we're going to replace is whatever is the text at index. So, when we were looking at, A, we want to make sure that we want to take A out of alpha so that it's not possible for that to show up in as the new character. in the replacement. So let's run that and see if we get a passing test. Yes, and so that passes all of the tests. That was kind of a really little tricky thing that I added in just to be very sure that we were really getting a change in every position and that we wouldn't accidentally replace a character with the character itself. So under your own conditions for the way that you might write this for your own purposes, you might choose to not have that option in place. So that's the whole program. Let's see if there's anything else here that I was going over. Yeah, the last thing was that in my field in biology, um, uh, we see these kinds of mutations all the time, and this is actually where I got the idea for this program is that you could take a string of DNA and over time. Bases can be randomly mutated because of just mistakes that get introduced in the copying mechanism, and sometimes those mistakes can lead to the death of the organism, in which case they don't get propagated. And sometimes they can lead to um, fortuitous mutations. In that way, they would actually get propagated and put forward, and so they would become part of the permanent part of the genome. So just something to think about. These kinds of mutations happen all the time. And in biology, they can not just be a change of a base, but a loss of a base or the gain of a base. So the string could get shorter or longer. Um, Something to think about. So in this, we looked at a way to change the solution. The solution here looks at changing the string itself. Um, and I'm going to show you one other solution that treats the characters as a list, and it makes it a little bit easier.